So hello guys, today we are going to analyze the Wisconsin breast cancer diagnosis using KNN. So here we are going to basically use our KNN machine learning model to analyze the data, train our model and test on the data. So let's see what is the code that I have written. So first I have imported the libraries pandas, matplotlib, seaborn and I have like from the sklearn scikit-learn which is the main library. I have like imported the main things which is the data set on which I'm going to operate, and like train test split which is a function I'm going to use later on, standard scalar an important function I'm going to use later on, and the k neighbors classifier which is basically the main function I'm going to use to train the model and like test on it. And there are some further functions which are going to like ease up our output and like making it more readable and showing it in a graphical and matrix form so that we can analyze like what we have done in the whole code. So let's see what I have done. So here's the step one, which is loading the data set. Here I have in a data variable, I have loaded a breast cancer data set, like which I have imported from the scikit-learn library, sklearn, and I have made here x and y variables, two variables. Here X contains data, which basically means in our in our data set there are around 569 samples and 30 features. Okay, so the features of the data set are contained in X of all samples. Like of all the features of all samples are contained in the uh, data in the X variable you can see here, and in data.target, which target is basically the output. Like if it is a Benigen or if it is a malignant case. So data.target, which is stored in y variable, it contains the output if it whether it is Benigen or if it is malignant case. Okay, so let's move here. I have used another variable df, and on this I have used the pandas library data frame function, like in which this basically I have converted like the data set I have which I have imported is basically in the form of arrays in form of numbers as to the numpy data set. Okay, so um, here I have used pandas library to create a data frame and creating the data set, basically organizing it in a like better form so that we can operate on it effectively and more efficiently, and we can read it also, making it more readable. Like here it contains in rows it contains X which contains all the features of the samples, basically the samples. Rows contains the samples and columns contains the features. You can see here the columns contains the features, 30 features, and X in rows we have all the samples. And here we have included a target feature at last column which contains basically the output of the whole thing, of the whole sample, like if the sample is malignant or benign. The target column contains if it is malignant or like benign, and here we have just printed the, you can see here target classes, the first five rows and target classes, it is nothing. So basically we have till now created a data frame and a matrix, you can say, which has organized our data set in columns and rows, samples and features, and the last feature is our main output, also known as target. So let's move to step two, which is exploratory data analysis. So it is nothing, it is not much important, but you can see it here. Like we are printing the shape of the data set, data frame, and you can see like here I have written like malignant cases y equals to zero. Like it basically means like the it is basically printing the total number of malignant cases, the data set, and you can see like malignant cases are represented as zero in our data set. Yes, and Bayesian cases are represented as one. Like in our data set, it is not written like malignant, or if it is Bayesian, it is just written zero or one in the output, or you can say the target section. Target section, it is written zero or one. If it is zero, you have to know, you must know that it is malignant, and in one, if it is one, you must know that it is the malignant case. And here is a sub-step simple visualization. Here we have used Seaborn and Matplotlib libraries here just to like create a graph which basically shows our data frame, like represents our data frame in the form of a graph. It basically consists of like, not, it doesn't represent all the features, it just represents the target. You can see it here in the x-axis. I have like taken the target. It basically shows like how much malignant and benign cases we have. I will show you the graph when the output will come, when we run the code at the end. So here you can see like the zero is represented by malignant cases, one is represented by benign cases, and the graph will show like how much malignant and benign cases are there in our data set. So let's move to step three, which is train, test, and split function. Like you can see x, we have made here four variables: x train, x test, y train, y test. So what are these variables? I will tell you, like I will tell you just now. But first, let's see what is train, test, split function doing here. So basically it is splitting our data set. Yes, it is splitting our data set into two parts. And how it is splitting, like in what ratio? You can see here I have mentioned test size equals to zero point 0.2. Like it is splitting our data set into training set and a testing set. So like zero point 0.2 means like 20% of the whole data set is going to be going in the testing set, and the remaining 80% is in the training set. Like 80% of the data we are going to use to train our model, and on the remaining 20% I'm going to test it. So yeah, what is random state 42 means? Basically, it just means that like whenever we run the code, like how many times we run the code, and the data will always be shuffled. But you taking random state equals to 42, the data, the shuffled data will always be same. Basically, we're manipulating the shuffling. Every time we run the code, the shuffling will be the same, and the division will always going to be the same. Like there is going to be no exchange, like some training data will go into the test data in the next time. No, it is not going to happen. So basically, X train, X test, Y train, and Y test. X train, basically we have made X and Y. We have declared X and Y here. X contains features and Y contains target. So X train contains the features and Y train contains the target data. Like features and target data of the training set. ठीक है? Okay, and like in the X test and Y test, it contains the like an X test, we have the features of the testing data, and we have the target of the testing data here. Okay. Right. So it is the train test split function. So now let's move to our step four, that is feature scaling. So in this step, what are we doing? So like you can see, I am using the standard scaler function here. Standard scaler is basically normalizing the features. So let me explain you this. Like let's say we have two features. The feature one, like feature one and feature two. Feature one has like, you can see like data less 1600, 1900, and 2100, which is very large data. ठीक okay. And we have feature 2 which contains small, very small data, like 1.9, 2.1, 2.5, 2.9, 2.7, which has a very small difference among them, and it is also very small. So you can clearly see see that the bigger data, that is feature one, which is in thousands, is going to impact more on the prediction, which is going to impact more on the prediction and all. You can see here. But what we need here is every every feature contains contributes same to the prediction. So prediction, or you can say the ML model. So to do that, we have to normalize every feature, and like we have to like scale them on a similar level so that they could all contribute the same to the model. So for that, we use the standard scalar function here. We used fit and transform. So fit function basically calculates the mean and standard deviation of the mod of the like data. Like we have used the training set data, and we have used uh, transform here in the on the testing set data. Like you can ask me like why we are like using fit data only on the training set and not on the testing set. So here's the logic. Like fit is function basically calculates the standard deviation and mean. So we are not going to calculate it for the testing data here. So we are going to use the standard deviation and like the mean for the mean to for the training data only, and we are going to use that standard deviation and mean on the testing data to transform. Like we have calculated the mean and standard SD, and now we are going to use that data to normalize the training data, and now we have used the same mean and SD to normalize our testing data, testing feature data. You can see the feature. You can see the features. We have like normalized the features of the both the data sets like training set and testing set, and using the SD and mean of the training set, and so that we can use it for prediction. Basically we are going to predict about the testing data. That is why we are not going to calculate the mean and SD of it. And here's the step 5 where we are going to use the knn training model, the knn classifier function, which we have imported from sklearn library again, and we have chose key as 5. So 5 we have chose key as 5. Like we have to use like small number of k, like we can't use like very large number of k, so that will take more time to calculate everything, and it will be more complex for the computer itself also. And we have chose key as odd because if it is even, there can be a case of contradiction like two or two. Like it can be classified as two or two in the two groups. Like two neighbors, it can be of the one group and the two other from the another group if it is four, and there can be a case of contradiction. So we use five so that there will always be inequality, and one and it the data will be always classified and it will be on one side rather than being contradicted. And we are used here and we used like the KNN data on the training set. You can see KNN.fit, xtrain, ytrain. We are basically training our model. We are using the train data to train the model, KNN model like which we have created here. And you can see in the step 6, we are using the testing data, x underscore test, which is our testing features to predict the output of the of the testing data. Like to predict the output of testing data, we have used our knn model here. You can see and predict function on the testing data, testing features. So now you can see I am printing the accuracy and using the accuracy function here. Like in which in y test we have the outputs, the actual outputs of the all the testing data, and in y prediction we have the predicted outputs which our model have predicted of all the testing data. So we are checking if they are all matching or not. And you can see here we are like making a classification report also. It is it is a function like we have all it is a function that we have imported earlier on. We have seen it, and we are making a confusion matrix of the like of the output we have created. So you will see it when I run the code. So it's time to run it. So far guys, finally it's time to run our code. So let's see how our model works out. So like it will take some time. So let's just increase our terminal. Oh, so here we get our figure one, which is basically the graph. So let me show you like what graph it is. Like here we have done the simple visualization. Here you can see the like where I here I we have plotted malignant and benign cases. And let me show you, like you can see it here. Like let me show you clearly. Here, like you can see, around some 200 plus cases are of zero. Zero basically defines malignant cases, and one defines the benign cases, which I have already told you all, which is around 350. Benign cases are around 350, and malignant are 200 plus something, around 200. You see around 570 cases are there in the data set. It just represents that only. Like the target is on the x-axis and count is on the y-axis. So let's move further. So here we get our second figure, which is the confusion matrix, which we have printed at the last. So let me show you like what. Let me first show you like what we have printed in our terminal. So in terminal we have printed here the accuracy, which is around 94.7%, which is great. Like around 94.7% of our predicted data match the output, the target of the testing data. Like what we have predicted, around 94.7% of it matched the data of the testing output. And here like we have what we have printed is the classification report. Like here you can see like what I have. You can see it is just a function like which shows accuracy, macro average, and weighted average. And now let's move to the confusion matrix. So what is a confusion matrix is basically like shows, it basically like compares like how our model performed, and like in how much cases like it has predicted wrong, like where it went wrong. So let's see. uh, here in x-axis we have the predicted cases, and in the y-axis we have the actual cases. So you can see here like here is malignant and is benign. So the predicted malignant and the actual malignant. So around 40 cases are there in which the actual were also malignant, and our model predicted is also malignant. So in 40 malignant cases, our model succeeded. And you can see in 68 cases are there in which the actual is benign, and our model predicted is also benign. Here our model, 1468 cases, our model predicted correctly malignant and benign. But there are three cases in which actually the output was malignant, but our model predicted benign. And three cases also were there in which the actual output was benign and our model predicted it malignant. So here our model went wrong, due to which our accuracy dropped down to 94.7%. So that is all for the video. Thank you.